Everyone, thanks for coming. And I'm Alex. I'm going to talk to you a little bit, a little in general, a little more specific about Eclipse Collections, which is a fairly new member of the foundation. So I hope that it will, kind of the connection will grow. So the detailed part of my talk is about what we've done to make working with Java 8 better. Probably not many people are very familiar with Eclipse Collections. Actually, can I have a show of hands who knows something specific about it? Minority? All right. So I'll try and make sure that we sort that out in the outline section. But then we'll look at the Java 8 things which we've done recently. Yep. No, my. That's not in the way, is it? Or the computer's fine? OK. I will also go into some comparison about parallel, which both Eclipse Collections and JDK streams offer, but in somewhat different ways. So that's our program, and just a bit about myself. I guess the main point is I've used the library and its predecessors, actually, quite a bit. I'm not one of the sort of main developers or committers, but I spend a good amount of time with them. Good enough, I hope. Right, so what is it, and why is it, perhaps? Because, collections library, there's one in the JDK. There's already some other open source collections libraries out there, so why more? And these kind of descriptive points that I have here, I hope illustrate why. So one thing is that it's quite extensive, so it gives you a lot. It's kind of philosophy, if you like, is of abundance. It's not like, I want to have something in the library. Well, no, we don't do that because da-da-da. It covers a lot of ground, as you see soon. It has a functional API style in the sense of functional programming languages. So, someone coming from your Haskells and Scalas would be happy to find this sort of thing in Java, whereas a few years ago they might have been very disappointed. It not only has types and interfaces and so on, like some competing libraries, if you like, do, but it also has many implementations of collections, with an eye to the next point, which is about efficiency, that we want to be compact in memory use and we want to be fast. So these are the very important motivations in the library. And there's some quite nice training materials. So there's a kata kind of hands-on exercise that you can take because, as I said, it is extensive, and that means for a beginner it might be a bit daunting, but we have these materials to help. My colleagues have been actually running some of these. They ran a couple-hour version of this at Eclipse NA last year, I believe. So we try and make an effort to get people oriented. A little bit of history of the thing. It actually started quite a while ago. These are predecessors, if you like. I mean, obviously it wasn't Eclipse Collections then, but the first kind of stirring was more than 10 years ago. Was motivated by the observation that JDK collections were not very good when there's lots of small ones that you're using. They over-allocate their backing array, that sort of thing, and your app uses too much memory. So that was the initial sort of small motivation to implement some collection things ourselves, and then it went from there. Pretty soon, the small talkers on the team back then decided that, well, I want my higher order functions. What kind of language is Smalltalk, by the way? People know, I presume? Yeah. You said OO?
You asked who knows Smalltalk?
What kind of language is it?
It's a function.
Oh, you say functional language? Well, that's amazing. I mean, I always heard of it as being an object-oriented language, but it's very interesting, right? I mean, it definitely has that angle. So you end up with a library inspired by Smalltalk, which is quite heavily functional, I'd say. We'll see some of those, some examples soon. So then things chugged along for a while. A lot of things were added. I'll show a few just now. And in 2012, it was the initial open sourcing as GS collections, Goldman Sachs collections. This was a kind of half open sourcing, if you like. It was on GitHub. It had an open source license. But it was not possible to take contributions. So it was kind of a step in getting it out there. And that really completed, you might say, with Eclipse Collections last year. Now it's being part of the Eclipse Foundation. It's open in all the ways that an Eclipse project is open. Right. So I said it was extensive, and I'll fill up the slide for you here just now to sort of illustrate that in a bit more detail. But let's start with some interfaces and methods, functions that they have on them. So this is what is in Eclipse Collections, right? So it has interfaces for the usual suspects of your list, sets, maps, some of which extend JDK types, some of them don't. And additionally, there's a few variations on those, like bags, which are like multi-sets, multi-maps, bidirectional maps, so a few derived things, if you like, that are there largely for convenience, but they are useful. And most of these things have a full suite of methods that, as I kind of mentioned, someone coming from a functional style language or Smalltalk might expect. And I've listed some of them here. On the left in full black are the actual names in the library, and in gray I've put in some other names which are often used for the same thing in other languages, like many people might see collect and wonder what that is. It's just your standard functional map, and select or filter, inject into, sounds painful, but it's just fold, etc. So that's an outline of some of the methods available there. And as I said, there are implementations, an array-backed list, hash table, which provides really both hash map and hash set. So these things are implemented from scratch, and especially the hashing ones fairly differently than what you have in the JDK, with an eye to what I mentioned before, efficiency, especially for memory consumption, minimizing that. So for example, the Eclipse Collections hash set you'll find has about a quarter of the overhead of the JDK one in its internal structure. So the JDK hash set is a bit of a nightmare in that sense. Right, so now we get combinatorial. Both the interfaces and the implementations have kind of fork or bifurcate along several axes. I'll just go through these now. One is mutable and immutable. So most of these types exist in these two forms. And the immutable ones especially are, if you like, strongly immutable. They don't extend JDK types because those are too mutable themselves. They have add removal methods. So the Eclipse Collections immutable types don't extend those. So you're much less tempted by some autocomplete in your IDE to write some kind of mutating method on it. Another one is the way that the methods and functions are evaluated. There's three variants really: eager, lazy, parallel. I'll just mention briefly. Eager means that when you run one of these functions, like say collect, it immediately constructs a resulting collection. So if there's a list, you run collect on it, you get another list, which takes up space, right? Lazy means that evaluation is delayed as long as possible. And I'll have an example in a second. And parallel, this may be obvious. I'll just note the Java 8 streams are which is where these kind of functional APIs lie in Java 8 are only lazy. So you might not think of Java as catering to lazy evaluation, but Java 8 streams are they're only lazy. And the final one, again, you can pretty much pick any combination of these, is object or reference types versus primitives. So you have a full range of interfaces and implementations specialized for primitive types. You might imagine, especially when maps are concerned, where you have values and keys, and you have the full choice of key and value combinations. This results in quite a lot of interfaces and classes. But they're there. They're whatever you need in your project, right? You might need a long to byte map. No problem, it's there. So that's sort of the extensiveness tour, if you like, here. Any questions? Or? And just a quick example here before we move on to the Java 8 stuff. So I have a example toy domain model to use in the use for examples where you have a position or inventory, you might say. You have stuff in your warehouse, or in my in my motivation, you have financial products in your books. And a position is associated with a product, which has a few descriptive things here, and also an account of who's the counterparty. So straightforward example. And so illustrating several things here. There's one is how you construct things. There's a kind of little factory system that looks like this. I mean, this just creates an empty list, so just for an example. And you have this immutable list type here, which is one of the options I mentioned. It's one that does not extend Java util list. So if you got yourself one of those, and you plan to do a bit of processing on it, like get a set of the accounts which have products with a price greater than something. Given that you're planning to do two operations here, so this here is a filter, select, and collect is a map. So select picks out the positions which satisfy this predicate, and collect will, for each one, will extract their account. By the way, is the lambda and method reference syntax clear to everyone, or that's not something new? Right. So because you're doing two of these, it's actually good to do this lazily, in the sense that you're not going to create a list here after this step and then create another list after this step, right? There'll be wasteful intermediate objects which maybe are big. So we just stick a lazy conversion here, and then these guys will not evaluate until we actually force it to produce the result, a set. And then the whole thing will happen in one go. So yeah, there's this construction, lazy conversion, some of the methods here, and then another conversion. Right? So on to Java 8 then. So this is a bit of a plug at the beginning, I guess, is that this library had these features long before Java 8 came along and brought them to the JDK. Certainly the higher order function API was there since 10 years ago or something. Obviously this idea has been around much longer than that, but someone coming to Java back then didn't really have that many options. So that all existed. It was a bit awkward because you had to use typically anonymous inner classes to represent the processing that your maps and filters are doing, right? Which is a pain. But that's what we had, and we had some provisions to help with that. But all that's not that important anymore because Java 8 came along, and it did a pretty nice job of being flexible with how lambdas are converted among function types and that sort of thing. So right off the bat, the GS collections at that time, I guess, worked well with these new features. So you could write this code even though the actual type of interface that's given to select is not. It's an interface defined in this library. But lambda conversion being flexible, that's not a problem, so it works. But there was initially no, the Eclipse collections didn't require Java 8, it didn't depend on any of the new types or features or anything like that. So that was fine, and now in version 8, which was released a month or so ago, I think, Java 8 is required, it's used somewhat, and using the libraries together has been made more convenient, as we'll see the details in a minute. So another quick example of Java 8 streams. Is that familiar to everyone? If you want to do map, if you want to do these kind of high order functions, then you're obliged to obtain a stream. And you're pretty much obliged to do something like this collect at the end, which unfortunately name clashes rather severely with the Eclipse Collections Smalltalk inspired method called collect. They're quite different, but there you have it. So the collect here takes a collector, which then performs some kind of reduction, or if you like, dumping operation into some other type, which then comes out, in this case, a list. So here's two lists, and that gives us a list. The design is kind of funny, I guess. The collect method is so relied upon to provide the generality in the streams API, because the number of these kinds of methods is quite limited. There's like map, filter, flat map, and I think that's about it. And all the other possibilities are kind of bunched into that collect and collectors. Okay, so what does the integration look like? Well, and I'll note here that other libraries that maybe are thinking of kind of improving their posture with Java 8 could use similar techniques. So Eclipse Collections had these function types. We'll have an example in a second. And we made them extend the newly introduced Java 8 types, like function and predicate. So that brings them closer together and provides some opportunity for reuse across between the libraries. In addition, we now provide a set of collectors which can be used in here to produce, instead of JDK types, to produce Eclipse collection types here as a result of Stream.collect. So enumerate some of those shortly. And finally, we allow collectors which may already have been written to be applied on Eclipse collection types from which maybe you cannot obtain a stream. So you would, at first sight, have no way to use these collectors, but now there's a method added which lets you do that. So let's dive into the details here. Don't want to spend too long on this, but there's, just look at one of these. There's a functional interface, I guess, a familiar notion. In Java 8, an interface with a single method, which can be the target of a lambda. Like if you write a lambda, Java will produce an instance of any matching thing like this that has one method. So before Eclipse Collections had this function, and now it extends the Java util function one, introduced in Java 8, and it already had that. It extends serializable, because that was considered important. So this isn't anything new, it's just I put it in there for information. I don't want to look at the others, they're just variants on that theme. There's a function 0 that's like a supplier, and there's predicates and primitive involving functions. So there's quite a few of these functional interfaces, and they've been made to extend the standard ones where possible now. Want to move on to a couple of more interesting things, perhaps. One of them is, as I said, we now supply some collectors that, in fact, kind of the Eclipse collection lead, if you like, gave a talk at Java 1 about this year about the potential collectors marketplace. So there's, I don't know, it's maybe it's going to be a thing where, because Java 8 streams kind of emphasize these so much, that there might be some potential for even going to a marketplace, right? So there's quite a lot here. This collectors2 class is a class in Eclipse Collections added now, which has a lot of static methods which give you Java 8 collectors. And so then you take one of those and you put it in your Stream.collect method, and it gives you, so here I illustrate this. So this collectors.toStack, for example. So if you run that on your stream, you're going to get an Eclipse collection stack. So all these here, this is just an extract and some examples. All of these have no parameters, and they produce whatever their name suggests, right? So they can produce almost anything. There's it's kind of duplicating functionality, if you like, but we have collectors in there which do the same thing as the corresponding methods, like map filter, known as collect select. So those, for example, for this guy here, you would supply a predicate to do the filtering. And you would also supply a factory method reference, probably, to say what kind of collection you want to get out of it. So you could get one of a range of collections. I'll have an example just now. There's several grouping type collectors which do a grouping by key, producing some kind of multi-map, where is a multi-map a clear notion? Just say it's a map of a key to a set of values, right? It's always not a single value, but a set of values. There's several which produce either primitive collections or just a single primitive type, like summing to some primitive value, or mapping to a primitive collection. So, for example, collect Boolean will produce some kind of Boolean collection, which is a primitive Boolean, right? I mentioned we have a kind of full set of primitive collections. A few miscellaneous ones here, and then a couple which make use of pairs. So pairs, again, are a fairly standard functional language construct that is included here. General pairs, that is. Okay, let's look at a few examples. So same position account product model there to play with, and let's say that we have a JDK list, so a standard simple list of positions. Somehow we have one of those, and so here's one example. As you tend to do with streams, you call .stream, getting a stream. You might do some things on it, like map filter, whatever you want to do with your stream. And then you pull out the big hammer collect. And now here you use this collectors2 class I mentioned. And in this case, it's a collector which will do a filtering according to this predicate, price greater than something. And it will produce for you a collection which is created using this method. So this again, I mentioned, is like the little factory subsystem within the library. And as you can see there, you get a mutable bag consistent with that. Fairly similar, a grouping operation where you supply a grouping key, and you also supply a factory for a multi-map in this case. And so it'll group by category, which is a string. That's that string here. And the values in the multi-map are logically sets of positions, right? But the actual generic parameter is just position. It's the type here captures the multiplicity aspect.
So what's the benefit of the first example instead of using stream, filter the lambda expression and then collect to a back collector? I don't see the difference.
No, not.
New API to learn instead of the existing.
I asked the same question. I think because I didn't author this, but and it definitely does duplicate functionality elsewhere. The aim is either if you have some specific case where it may be more beneficial to, instead of having separate filter and then conversion, to just do it in one shot, but also as a kind of illustration of, because the collectors too class almost sort of has pointers to everything in the library. But you're right that you may not necessarily want to use every single one. The library as a whole tends to have a lot of options, which, yeah, that's not kind of Python one way to do it. So something to keep in mind. Right, so don't really want to spend much time on this. There's just two other points, summary statistics, and which is a Java 8 introduced thing, and optional is also Java 8, so there's a few things added to Eclipse Collections making use of those, but let's hop on a bit, because I wanted to, I'll just mention briefly here that so in Java 8 you have Stream.collect, right, and you put a collector in here. So we added a method on for Eclipse Collections. RichIterable is sort of the base interface that defines many of the methods that I mentioned, but then there's a whole big tree of types underneath it. So we added a method reduceInPlace, which does the same, not does the same, but produces the same result as Stream.collect, so that if you happen to have collectors lying around, you can just put them into your Eclipse collection type and have them be executed the same way. So let's not look at the implementation, but so you may maybe note that it's quite straightforward, largely because it only caters to the serial case, whereas Java 8 streams also come in a parallel form. However, there is also parallel, fairly complete set of parallel execution options in Eclipse Collections, and the way that those are done, they're kind of separated by type. You have a parallel iterable and some tree of subtypes underneath it, which is used to do parallel execution. And if you have some Eclipse Collection standard class, whatever object, whatever it might be, you call as parallel on it, passing it some details about the parallel execution that you're going to do, and then you get back one of these guys, which has the same set of methods as before. Right after that point, you just use it as if it was a normal serial type. And just to contrast a bit the way that the parallel execution is done, the Eclipse collection approach is say maybe simpler, that there is a interface to split, say, a list. You have a list, you're going to do some operation in parallel. So using this, you would specify how to split it into chunks. And then the kind of parallel execution engine will take those chunks and throw them at a normal Java executor to run in parallel, and then combine the results while trying to avoid to reduce the cost of that combination or merging. And that results in parallel execution, which is usually faster than Java 8 parallel streams. And additionally, because you get those parameters, the executor and the batch size, you can actually cater to at least the distinct cases of CPU bound and kind of high latency I/O operations that would usually benefit from different executor and batch size settings. On the other hand, JDK 8 streams implement parallel execution through the splitterator interface, which again, the role of that is to be able to split your task into bits that can be executed in parallel. But this one takes a different approach of doing just two-way splits, but quite likely recursively. So we'll split in two, then split in two again, or whatever makes sense for the data structure, for the exact structure that you're working with. And that execution is then thrown at a fork join executor, which supports this kind of recursive decomposition. And that's quite general. I mean, you can take any type of structure, like a tree, for example, which I'm not entirely sure how you would split up a tree operation into a list of n batches. So that, I think, maybe illustrates a limitation of the Eclipse Collections approach, whereas here you wouldn't really have a problem using this recursive two-way splitting. And we've observed this in performance testing using JMH and such, that this has higher overhead and ends up being slower. Certainly for the common cases, your lists and such. Well, I think we would implement this reduceInPlace parallel at some point, and the way that would be done is to stick an implementation underneath this parallel iterable, which at the moment isn't there. So you're in your ID, your autocomplete is going to sort of hint to you that you can't do this at the moment. But if we were to add it, we'd just add it using the same structure as exists already. And that's it with a few minutes for questions. Links here, I mean, I guess we'll get the slides up at some point, right, probably, so that the links can just stay with that. So there's other talks of various kinds. Maybe I'll put this one up while we talk, because it's strictly speaking from last year, but I'm not sure if anything much has changed. So comparison table for the different collection libraries. And yeah, questions?
Maybe one question. You switched to Eclipse recently, not but a year or two?
Less than a year, no, a year, yeah.
What's changed for you? How your life as a project changed since you moved to Eclipse?
Well, I kind of caveat that with that I haven't been that involved with the actual kind of day-to-day running of the project. But so for the people inside the company who are the ones who are mostly the committers now, it's kind of turned the everyday development operation around. Before it used to be the development is done internally and then a synchronization is done to GitHub. Now it's the other way around, as all the work is done outside, just like any Eclipse project would be, I guess. And then for use in the firm, we obtain it through Maven or whatever. So that's kind of turned around. And a very big one is that there is at least the full possibility of having other contributors, which we kind of just couldn't fit into our setup before this was done. So, yeah. Yes.
Do you have any rough performance comparison between the Eclipse Collection and the Java 8 Stream? I know you did performance tests, as you said.
Yeah, I'd say just pull this guy up here. There's this focused on the parallel lazy performance because that's really what Streams has. But I think the first set of graphs were for serial execution. Yeah, on the whole, it was Eclipse Collections was faster. So, and I mean, one reason given for that is the kind of quite high code reuse approach used in JDK for Streams results in some additional overhead and certainly in kind of simpler common cases. I think it was a little bit speculative, but there's details in there. So. Yep.
What was the choice that the function interfaces are serializable? Or is it legacy?
No, not only. There's, I asked about that also, and it's just useful to be able to stash instances of these things in a serialized form.
I would like to reference Brian Gutt's talk about lambda expressions and the structure of the lambda expression, and he mentioned that the performance penalty at creation time and especially at performance optimization time is more increasing the serializable function interfaces.
According to my colleagues, this is not an overhead that you encounter just all the time. It's maybe related to one-off tasks like class loading and that sort of thing. But I mean, are you talking about cases where you're not actually using the serializable?
No, he did mention that they are not planning to optimize for serializable functional interfaces because it's a corner case for them to serialize subjects. I mean, the
one thing was that there were two fairly recent libraries which had gone the same way. There's, I believe, Oracle's own coherence. Is that like a distributed memory solution? Is that right, coherence? That has function types which extend serializable, and you can imagine why that is. I mean, if it's a distributed application, they might want to send these things between nodes and that sort of thing. So that's the use case, and it has been useful for us. And I asked, and they said that we're not intending to change that. Yeah. All right.
Hey, thank you.
Thanks.